everyone, and welcome to MajorDom's 11th DePIN Workshop on YouTube and for Moonchain. I hope you reached already, and yeah, would like to start with an intro for today's presentation. Today we'll have a deeper look into MEP-3355 and how it's used to process data on the Moonchain blockchain for make it possible that the data can be used with an LLM. The second step will be that we have a comparison between how Web2 and Web3 protects data and how the data is handled onto the two different technical aspects. The third point would be a short look into the economic value of the blockchain data. While blockchain data is publicly, but it's not a free data. So just because it's open and freely accessible doesn't mean that it's automatically free data. Specifically when you want to use it in a large way. The next step will be a comparison between two specific products which use health data, so important data, and it's important to use these data or to operate with this data in a secure way. And for this, I will show you a comparison between the Blueberry ring, which is an upcoming product from Moonchain, as well as the Aura ring, which is an older Web2 product, which also has a health ring opportunity, I would say. Or not opportunity, which uses a health ring as its product. Sorry. So, like I said, at first we will have a look into MEP-3355 once more. What is MEP-3355? Like I already said, it's an LLM-friendly transaction memo format, and it's specifically used for transaction memos on Moonchain, which should be used in an LLM for using these data to give an insight of it with the use of an LLM. I also will show you an example for this today. And why is it important to use it? So when you would imagine you have a large chunk of data and you want to send this on blockchain or want to save it on the blockchain, then of course you have pretty much high gas costs which you have to pay for. And because of this, we thought about how we can solve this problem and provide a better solution for it. And by this we came up with the MEP-3355 proposal, which, like I said, is a compression format which uses the Broadly algorithm for compressed data. And yeah, I think the benefits I also talked about. I will show you some examples for this. Sorry, it will take some time. Already on the next slide. This was not what I intended to do. So here, once more, this repository also is referred in the description inside of our video of the workshop screen. Today. If you want to fully understand it, I think it would be helpful if you would have a look into it. Here we can see how specifically the data is provided when we use MEP-3355. It's provided in JSON object, and for sure you have some operation fields which explain how the data is used, and here down you have fields with the compression algorithm, which I already said is Broadly, as well as the content. And I want to show you one transaction which was made by our Moonchain ring. So here we are currently on the Moonchain Explorer. And this transaction hash you can see here is the same transaction hash which you can see here on the Blueberry app. So this is our mobile app when it comes to using our Blueberry ring. It's the same design when you use it mobile. And when I take this transaction hash, so I've copied it already, and go into here, then we can see, okay, it's the same, but nevertheless, I want to, I pasted it currently, and I will reload it because this will take a lot of time on my internet connection. We can see here the raw input of this transaction. Of course, it makes more sense to look into it as UTF-8 in the UTF-8 format. And like I already said, here we can see this JSON object which I showed to you guys for prior. So we have the format and the version and the metadata fields. All these three fields you can find here also: format, version, metadata. Sorry. Then you have the data source, data collection method, preprocessing, which are fields you can also find here. Data source, collection method, preprocessing, data, and here we get to the interesting part of this JSON object. We see the content, we see the type, and we see the content, and what's necessary for us is now the content. And we take this content and go into a broadly compression tool. Ah, damn, sorry. This wasn't necessary. Yeah, my mousepad doesn't like me that much. So I paste it once more, and here we can see the not compressed data. And when you just compare how much data we have here on the right side, and in comparison how much is on the left, you can see already that it definitely makes sense to use this kind of compression algorithm. I also want to show you that this data, which is showed here, and which I, like you have seen, took out of the transaction data, or the raw data from the transaction, is the same data which we can see here in the user interface, for example. So, no, this is not which was the field I wanted to take? Genau. Because I have to take the right field because I'm not fully sure how this data is pre-processed. Because when I look into, we have somewhere, yeah, here we have steps. So these steps are in kilometers calculated as well as calories, and in my opinion, this is not the step value. So I have to use another way to show you the data, and for this I decided to use the oxygen value, right? So here the last three data points are 100, 98, 100, and before the 199, 100, 98, 100. So let's see what we have here. Yeah. No, this is... Ja, doch. 198, 199, 198. So, sorry. So these 5 data points are specifically the 5 data points which are shown here in the last, or in the diagram. So you can see that we use these data directly in our DEP, in our user interface, and it's compressed and open lying on the blockchain, which brings me to the next slide, I would say. The comparison between Web2 and Web3, how they handle our data. And I would like to start with Web2. I hope the slide is loading soon. Yeah, in Web2, what is Web2? Web2 is a traditional internet. Web 1 was the beginning of the internet, where companies, or not companies also provided data, but you mainly could read these data. You couldn't interact with this data. So Web 2 is the internet we know nowadays. You can interact with these data, you can provide data on your own, and this is Web 2. And just for information, Web 3, I think the most people which are watching this stream right now, I hope a lot of them don't know it already, but I think the most will do, is for sure the decentralized web, in which we interact on a blockchain, and for interacting with this, we need a key pair. And this key pair makes it possible for interacting with the provided services just by using this key pair, and not have the need to interact with it via providing personal informations like KYC or something like this. The KYC on blockchain is mainly because of the Web2 influence and the yeah, influence of the real world onto the blockchain technology, and not because it's necessary. So yeah, so I overflew a little bit what I wanted to tell you about Web2. Um, there, the data management is mainly controlled by centralized entities. Like when you think about Google, there the data is stored specifically on the Google servers, or Facebook, Amazon. These companies also, you have to trust this company when you use their service. Then you fully have to trust them that they don't sell your data like it's not intended, or like you don't allow it to them. Or your data gets lost when it comes to a cyber attack or something like this, a breach. And because of this, all your shared data is now readable for everyone in the internet who wants to read it. Yeah, and for this, Web3 brings the opportunity or the possibility to decentralize all this data management, in the way that the data which is stored on the blockchain, it is not stored on just one server, but on every node on the blockchain. And this brings me to another up point, yeah, sorry, another good thing about Web3, which is when you think about a Web2 service which runs in the cloud. Like think about you're using an e-bike, and this e-bike provides some services, like where is my e-bike or something like this, via an app. In Web2, these app definitely runs in a centralized way. So as soon as the company which provides this app don't pay for this app anymore, all the functions which are provided by this app won't work anymore. And just a few months ago, I heard about a Netherlandish bicycle company who had exactly this problem. And the customers who bought the product from them now has the issue that some parts of their product they can't use anymore, because they trusted a centralized entity when we want to break it that far down. And yeah, for this, Web3 also brings the benefit that you are able to provide decentralized services also. Not only data is possible to provide in decentralized way, but also, yeah, whole applications. And by this, you providing a way safer experience when it comes to losing the service, or losing the entry to the service. So I think I already told you how this is implemented in Web3. Like I said, for this we use cryptographic key pairs, which consist out of a private and a public key. The public key specifically nominates to the wallet address, which is open for everyone. And if you want to do a transaction with your wallet, with your private public key, then you have to sign this transaction with your private key. And with this, you allow the code which forms the wallet, I would say, to handle the transaction in your allowness. And because of this, it's pretty important to don't share your private keys when you are interacting with Web3, and also look for a good way to store them. Because everyone who has your key has the full control over it. But this also is a good part, because which I want to tell you in the next slide, is the pseudonymization, which is brought by these public key infrastructure. Because all your data is only referred to the public key, you can stay anonymous. When you think about you're interacting with a data-sensitive app, you would be able to set up a new wallet only for this. So your key pair would only be used for this specific application, and by this it wouldn't be possible to match your data with some other sensitive data application you are using, because when you decide to use every time just one wallet only for this service, of course you have to think about how you secure your keys. But for this we also have technical tools like a key storage or something like this. And yeah, with this you would be not only able to pseudonymize your data, but also be anonymized by this. And how is it done? How is it possible to share these data in a GDPR compliant management, or in a GDPR compliant way? Of course, because your data is only referred to the public key and not to your name or your date or anything which is or your address, anything which makes it possible to refer to you as a person. So it's able to use these data. And the other point is, not Moonchain as the company provides these data, but you as the user decide to provide these data, which brings me also to the next step, but I'm not fully done with this slide, sorry. Because I want to introduce you once more with the pseudonymization part. When the blockchain was hyped like 5 or 10 years ago, when everything started, for the most people, using a blockchain was automatically an anonymized way to interact. But because we use a public key pair, it's just a pseudonymization. Because when you think about if you would use every time the same key pair, the transactions which are done with this key pair are openly on the blockchain. So if anybody would like to connect all the transactions which are made by one wallet, it would be possible to de-anonymize the transaction which will be done. And for this, yeah, it's important to know the difference between anonymization and pseudonymization. Yeah, and like I said, the solution for this would be to use a new wallet for each application. Yeah, to minimize the risk when it comes to exposure through pseudonymity. And yeah, once more, the data in Web3 is provided transparent and under the control by the user. So by this, we meet the requirements of the General Data Protection Regulation, and the user can decide at any time which data they want to share and with whom. Um, you don't have to provide your data on the blockchain. You don't have to use these servers. But if you decide it, you have an opportunity to use IoT devices which is providing health data in a way more secure and privacy respecting way than if you would do it on the Web 2. Because like I've said on the second, or no, on the third slide, you have to trust your Web 2 intermediate. And this doesn't is necessary when it comes to using a Web 3 service, or at least using Moonchain. So because we definitely looked into how can we build our applications in a way that we don't have to use the data which is not openly provided by the user, which is only the public key. Yeah, and by this I want to go over to the next slide. Sorry, I'm on the wrong screen. So we come to the economic value of the blockchain data. For sure, because it's public and transparent, we have a lot of trust and security when it comes to if the data is valid. Because anyone can track these transactions, it's also way harder to make manipulations when it comes to separate single transactions. Yeah, this transparency makes it almost impossible to manipulate a transaction without this being noticed. Every change to the data would be seen by all participants in the network, which not only creates trust but also increases the security of the network. Yeah, every intermediate in the blockchain world would see when something malicious is done on the chain, and for this you would burn the sorry, I missed what I wanted to say. I ran into a corner where I don't have the right vocabulary to go further. I'm sorry. Um, like I started earlier, blockchain data you can or blockchain data is public, openly public, but only because it's public doesn't mean that you can use these data for free. And because we are still in the economic value of blockchain data, I want to introduce you with the cost factors which are necessary to run a blockchain. So, of course, there are the transaction fees which are necessary for providing data onto the blockchain or for interacting with the blockchain, for changing the state of the blockchain. And these transaction fees are on the other side used to pay for the infrastructure costs. Because the network needs some nodes which are running the network and securing the transaction which are done on the network. And of course, for bringing up this infrastructure, the people also want to get some revenue. And here, the gas fee or the transaction fees are going to. And for this, it's necessary to get some cost structure into the openly used data. And when it comes to Moonchain, I think there are, or if you stay on Ether, we have two opportunities how we can use the data on the blockchain. Um, one way would be to set up your own node, which would need some hardware provided for running the node, and depending on the network, this isn't that cheap to bring up. Or the other way would asking or would to pay for the information you call from the blockchain. So by this I mean access fees when it comes to APIs. So when you think about Etherscan, you can use Etherscan when it comes to using it as a normal private user, I would say. But as soon as you want to set up a bot which automatically tracks specific transaction or specific events which happen on the blockchain, then you really fast need to pay for your API access, because Etherscan, I'm not sure how many API calls they allow per second or per minute or as a whole in a free subscription model. But when it comes to running a bot with a free setup and running and trying it in a PvP state, like it's sometimes on the blockchain when it comes to trading meme coins or stuff like this, or NFTs, or I think that most people know how often PvP is a term on blockchain. And indeed, if you would try to win against bots which are running on an own node or using or paying for the API calls, um, and you don't do it, for sure you get the information you want to have a lot later. And yeah, like I already said, blockchain data public but not free. And like I told, yeah, we have to pay for the resource consumption when it comes to bringing data onto the blockchain. Yeah, we have to pay for every transaction and every storage of data. We require significant computing power and energy. Depending also on the network, when it comes to Bitcoin, we have a higher necessity than when we compare it with Ethereum because of the proof algorithm. Because on Ether we use proof of stake, and not every node has to compute every block. But anyways, just for being able to store the whole blockchain and for being able to process the transaction in the way it's needed to um, yeah, being able to compete against other runner node runners, node operators, you have to pay for expensive hardware. So another point which is why the transaction fees are a good point, or can be a good point, is for sure the protection against abuse. When you think about, you have to pay for interacting with the blockchain or the infrastructure which is behind the blockchain, there is a much lesser chance for the danger that this transaction would be done by bots, because when you have to pay for it, you think twice if you want to use a bot for it or not. Yeah, and here we also come again on which I referred on the last slide. The fees are necessary to provide the sustainability of the network, help to finance the infrastructure, and enable the operation of a secure and stable network. And yeah, provides that the blockchain is a living system that is constantly evolving to become safer, faster, and more efficient, which requires ongoing investment. And like I said, if you want to interact with the data on the blockchain, you would have to run a node for being able to fully use the data in the full content, like it's stored on the blockchain, or the other way would be to pay for the API calls. So just for having these data public doesn't mean you can have it for free. And here I want to talk about the blueberry ring once more, as well as the Ura ring, like I already told you about, which also brings me to something which I forgot when it comes to broadly. Sorry. Um, Here we can see a script which I wrote to show you once more how impressive the compression rate of broadly is, but I think it's not that necessary because I already showed it to you when we had a look into the decompression. But anyways, you can see how really slow my machines are. It's crazy. Um, so you can see here is the private key, the public key, sorry, the public key I was referring to when I tried to explain what a Web3 application needs to from the user for function. So you don't have to provide your email address, you don't have to provide your name or anything like this. You only yeah, need a wallet, so a key pair for using our application. And by this, the only data which is referred to your um, data sensitive health data is a pseudonymized phrase. So it's nothing more than, I can show it to you. This is everything which refers on the blockchain to all these data. And by this you can see how beneficial this way of interacting with data as a whole and important or sensitive data like health data, yeah, specifically. I think the script also should have been run through. Not one. Please don't wonder. Here I implemented a generation randomization function which changes these values in here. So the data is not only multiplied by 1000 but also randomized. So all this data is compressed. Sadly, I didn't print out the compressed file, but I can change the script fastly if I find where my terminal ends. Okay, the compressed data is at first. Then I have to switch this. So I will run it once more. And while this is running, I think I can go into the comparison between the blueberry and the Ura ring. I just wanted to have a real example when it comes to compare Web3, the Web3 application, which is getting more traction in the world nowadays, with a Web3 application which solves the same use case. And yeah, for this I decided to compare Blueberry Ring as well as Ura. And yeah, just from the standpoint sorry anonymity and pseudonymity. I'm so sorry. Yeah, like I already told you, when we use the Blueberry ring, our data is pseudonymous storage on the Bluechain, and a comparison between us as a person and the data which is stored on the blockchain is not possible for anyone who wants to use this data. It's not possible for Moonchain as a company. Um, it's just not possible, and I think this is a really, really big benefit when it comes to compare this with a Web2 ring. I'm so sorry. Yeah, because there the data should be anonymized, should be, but you don't know it. You just have to trust your intermediate, which could be Ura, which could be Samsung. Anyways, your data is stored in a central storage and maybe also laying directly next to the database which stores your payment information perfectly. When then these two databases also are connected with each other, then all of your anonymized data is gone. And yeah, you have no control and no possibility to really check if you can trust these intermediate. You only can believe them, and from once in a while can look into the newspaper and just read about the company which has to pay millions and millions of dollars or euros or whatever because they didn't anonymize the data or they shared the data with somebody with they shouldn't share the data because it's forbidden from law. And yeah, you can solve all these problems just by using the Web3 approach of a health ring, for example. And this not only refers to the health ring. Web3 brings the user back the power to decide with whom he shares his data. Um, and I think this is really necessary to make the people understand for once helping the people and yeah, to get back more control about your life when it comes to this. Sorry, I'm once again on the wrong screen. Yeah, this also is interlocked with the prior slide. For sure, like I told you, the data management on Web3 is totally in a decentralized storage, so these data won't get lost. It will be there forever, but you have your full control over it to bring it there. And you also have the full control with which other applications you interact with the same wallet. So when it comes to uh, de-anonymize your own data, it's your fault. And it's not that you have to trust somebody that uh, won't will do it like it's in the Web2 world. You have the power to decide specifically against it. And yeah, in Web2, like I already said, the data is stored in a centralized way. Not only is the data stored in a centralized way, you also have to trust the company that it will still exist in 2 or 3 years when you still want to use your ring. Because, like I already explained with the bicycle company, as soon as the company don't have any money, they won't be able to still provide the service. And when the servers are not there anymore, the whole application doesn't work anymore. And with our concept, which is stored on the blockchain, you still have all the functionality um, on the blockchain for providing your data, for using your data, and you don't have to trust these Web2 intermediate. Yeah, then I want to go over to the next point, because here we talk about the reward system. I also mentioned it here on the last part when it comes to data management, the possible monetization through sales of the data, without directly communicate with you as a user. You don't have any control about it. So when it comes to and you don't get any benefit from it. So, and when you compare this with the Web3 approach, in the Web3, the user just, when they provide their data, they directly get provided with a reward for providing their data. When it comes to Blueberry Ring, it would be provided, would be a health token, which would be provided. And as soon as the data goes onto the blockchain, also your token reaches the blockchain. So it's not possible to share these data without getting the reward for it. And so you directly get a compensation for not only providing data, but also providing data which can't be matched to you as a person. And this is a promise, kind of. So in Web2, it's not really possible to do this promise. As well as in Web2, you don't get any reward for providing your data more than, yeah, how many steps you did this day. This is your reward. You get the information about your data. But this is everything. It's not that you get a monetizable reward, which is the health token. So the whole monetary benefit lies within the company. And when it comes to URA, as example, you also have to pay for specific functions from them. So if you want to use their AI insight, maybe as an example, you have to pay for this. When you indeed look with me into Moonchain and their Blueberry Ring, we just can ask an AI service inside of this app. For sure, we have to sign the transaction once more for getting the information. Okay, maybe it's not happening because I already done it. This is the information I got from the AI prior the workshop. It's so slow. Yeah, but I don't have to sign anything, I just see it currently. I hope you can hear me properly. This I just remembered about. Ja, der soll auch nicht verbunden sein. Der soll verbunden sein. Okay. You also have another opportunity to get an AI insight, which I don't use for today. Let's get some trading insights. And you don't have to pay for these services. You do assignment, but you You don't have to pay gas for this. You also don't have to pay gas for claiming. So depending on your level, you are able to claim once in a day and to share your data once in a day, or when it comes to it's not so deep knowledge. But anyways, currently we are still in the development, or the AI team of our company is still in the development of these features. I just wanted to give you a short insight of it. And I think with this done, with this set, I should be through with our presentation for today. Yeah, I am. I want to look into the live stream if I missed some questions on you guys. Sadly, this doesn't look like it, but I hope I could give you some insights on those topics. And yeah, in the next workshop, I will show you how you can develop NFT collection on Moonchain. And I think I also will be able to bring you guys a little gift also for taking part in the next workshop. Yeah, I would love if you join the next time again, and hope you could get more insight by taking part in today's workshop. Thank you and have a nice week.